Now we have to see unsolved problem from chapter 5. That is problem number 6. A container of mass 200 kg rests on the block of an open truck. If the truck accelerates at 1.5 meter per second square, what is the minimum coefficient of static friction between the container and the bed of the truck required to prevent the container from sliding off the back of the truck? First, understand the question. Now, one container having a mass 200 kg. Now, this is the container having a mass 200 kg which is put on a open truck. Now, this is the truck. On an open truck, one block is put and the truck is accelerate 1.5 meter per second square. In that case, what is the minimum coefficient of static friction acting on the block to prevent the block without falling on a road? Means the block will not fall on the road. Then in that case, what is the minimum coefficient of static friction? First, write down what is the given data. First, mass of the container, that is m is equal to 200 kg. Next, acceleration of the truck. Acceleration of the truck is 1.5 meter per second square. Now, what we have to find out? What is the minimum coefficient of static friction? Means mu s we have to find out, and we know that acceleration due to gravity g is equal to 9.8 meter per second square. Now, see here, suppose the truck can be moves in that direction, means accelerated, this truck is accelerated in that direction, means when this truck is accelerated in that direction, then the force act on the block, the force act on the block is in that direction, the force act on the block is in that direction, and the frictional force is opposite to that of motion, means in that direction the frictional force is act on the block. Then we know that the force due to the acceleration of a truck is in that direction and the frictional force is opposite to that of the force. Okay, therefore we know that therefore the force act on the block, the force act on the block due to the acceleration of the truck, the force act on the block due to the acceleration of the truck is equal and opposite to that of frictional force. Frictional force act on the container. Means due to the acceleration of the truck, the force act in that direction. Okay, when the force act in that direction, the frictional force act in the opposite direction. Therefore, force is equal to frictional force. Force is equal to frictional force. Okay, both forces are equal but opposite in direction. Okay, in that case, what is the force? Force is nothing but mass of the container and acceleration of the truck. Mass of the container and acceleration of the truck is equal to, that is the friction. Friction is nothing but mu s into n. Mu s into n, that is frictional force is equal to mu s into n. In that case, the normal force n is equal to mg. Therefore, m into a is equal to mu s into n. N is nothing but mg. Okay, m into g. This mass and this mass is cancel. Therefore, what you have to find out? Acceleration is equal to mu s into g. We have to find out a static friction. Therefore, mu s is equal to a by g. Mu s is equal to a by g. Then what is the acceleration? Acceleration is 1.5 meter per second and g is a 9.8. Therefore, the static friction is 0.153. This is the minimum amount of static friction required to prevent the container from sliding off the back of the truck. This is the minimum coefficient of a static friction.